Everyone, my name is Darnell Houck, and today I'll be presenting on 2D Maxines and their composites with a focus on a new synthesis method. To begin, we first answer the question, what are Maxines? Like graphene, Maxines are in a class of 2D inorganic compounds typically used in the development of energy storage devices like batteries and supercapacitors. All Maxines are derived from a bulk material known as max phase, with max being an acronym and each letter its own layer. The M denotes an early transition metal, while A denotes group 13 and 14 elements primarily, such as aluminum, silicon, or palladium. Finally, the X is either carbon or nitrogen. Maxines are created by taking advantage of the weak metallic bonding between the M and A layer, and because of the weak bonding, the A layer can be removed through a process called etching, leaving the M and X layers free to ionically bond to form Maxines. In recent years, Maxines have been receiving a significant amount of attention from researchers for a range of applications due to their unique physical and excellent electrical chemical properties. Their high electrical conductivity and superior mechanical properties have also made them a promising candidate material for innovating energy storage devices, which can be applied to a variety of applications as seen in the diagram below under the What Are Maxines section. You may ask yourself, why is this research important and what is the motivation? And it is because currently, as it stands, the most prevalent method to synthesize Maxines involves using hydrofluoric acid, or HF, whether in pseudo or not, as a chemical etching agent to remove the A layer. Now, there are numerous issues wrong with this method, but one of the most prevailing issues is the inability to scale up production due to the toxic and highly volatile nature of HF. So, to mitigate the risk of sailor production, the method my research group and I have been implementing involves using halogens as the etching agent as opposed to HF. The halogen mixed with an organic solvent reacts with the max phase precursor, removing the A layer, producing Maxines, as seen in the schematic here below. However, to truly know whether or not your Maxines have been synthesized, you must characterize your product by using X-ray diffraction and note the change in peak position. If the peak is 9.5 as seen by the blue line on the XRD plot, you still have unreacted max phase. If there is a peak on the 8.8 degree position as shown by the black line, you have successfully made Maxine. However, synthesizing Maxine is just the beginning. Although Maxines have increased electrical properties in comparison to, say, graphene, my research group aims to produce composites with enhanced electrical properties and enhancing mechanical properties by blending Maxine with cellulose. We are also planning to integrate 3D printed Maxine cellulose composite thin films into electrical devices to form new flexible batteries and supercapacitors. With that being said, I thank you all for listening to my presentation. I hope you all have a wonderful day. Bye.